discussion in this conference anyway. A little bit, we're going to pivot from talking about the standards that govern the actual units, the automobiles, the batteries, and how we test them under UL. And I want to pivot now towards how do we protect our buildings once these units, once these batteries, in whatever form they're in, wind up in the building somehow, whether it's manufacturing, storage, automobile parking, anything along those lines where there's a lot of batteries in one given place that could pose a real threat to the building, to the structure. Now, we've been designing fire sprinkler systems for over 100 years. We've got standards that govern automatic fire sprinklers and their installation, but we've never truly been confronted with a fuel package quite like lithium-ion batteries. And that's because a lot of times when we test out sprinklers, whether they're very large orifice sprinklers or even just regular standard spray sprinklers, we typically see a considerable reduction in the heat release rate of a fire, all the way down to potentially extinguishment of the fire. That's not the case with lithium-ion batteries. There is no specific fire protection product when it comes to active systems that will put out a lithium-ion battery fire once it starts. Your only hope is to contain it, to control it, until it burns itself out. Now, it happens that water is considered to be the best at doing that as long as you have a sustainable water supply. Now, in the United States, we have water systems that allow us to basically design a system to have water supply almost infinitely. That's not the case here in Latin America, where you are more prone to have stored water supplies. So you do need to pay attention to how much water supply you have in order to protect that. But let's take a look at some of the standards. Let's take a look at the challenges that we have when we're looking at designing a sprinkler system, designing this fire protection system to protect against a lithium-ion battery fire. So I want to focus on two areas here. I want to focus first of all on the manufacturing and storage process, and then we're going to go into an area where the second part of the presentation will be on automobile parking structures, because that is an area where there is considerable movement and considerable discussion, but also considerable exposure of individuals in areas in these buildings that need protection using automatic sprinkler systems in order to maintain structural stability. So the protection of the manufacturing process really comes in three stages. It's the manufacturing process itself, it's the batteries when they are being charged, and it's the storage of the batteries in and when they are ultimately being shipped out or being considered for further use. Now, as we've seen before with other discussions here even this morning, what we're focusing on right now is this thing called cascading thermal runaway. All right? And that is the process. You saw a great video of how that runaway process starts because of this combustible electrolyte that's inside the batteries that is suddenly escaping. And each time it escapes, it impacts other batteries and impacts more batteries. And you saw that kind of explosive reaction in one of the earlier videos. Now, one of the things that occurs here is this can occur through thermal abuse or heating up the particular unit, electrical abuse, short-circuiting within the unit, mechanical abuse, which is kind of damage that occurs to the battery from the outside, or internal short-circuiting. Now, what can result from those small battery fires is exactly this right here. This is a large battery storage, or it was a large battery storage facility in Northern California that was not protected by automatic sprinklers. It basically suffered cascading thermal runaway through damage to the batteries that were in it. This particular unit took all of in Northern California, it was the place where all the energy from wind farms and solar panel fields was all directed into these batteries to be stored. Once the fire started, that was it. There was no way to protect it, no way to stop it. Now, one of the things that you don't often hear about with this rather spectacular fire is the rekindle. Because even once the fire was out, 2 weeks later, the fire rekindled. Because there was still damaged batteries that were off-gassing the combustible electrolyte. So it was a large challenge. Now, there's been considerable research done so far on this particular problem, both large-scale and small-scale sprinkler testing, but there's also been large-scale sprinkler testing as well. And what we're basically finding out is it's a combination. There's a combination that has to occur between sprinkler design and some level of containment to make sure that when the units are exploding, when the units are off-gassing, that they don't spread beyond a specific area. So there's been some research on that basically shows or has demonstrated that water is still the best, better than foam, certainly better than gas systems, mainly because those systems are eventually going to run out of their fire suppression capability. You have to maintain certain concentrations, or you have to have a foam system that is actually continually delivering foam, because the heat from the fire will break it down. So water continuously applied is basically determined still now to be the best we have at controlling or containing these fires. Now, that being said, the protection guidance that is presented is limited. How do I design a sprinkler system to do this work, to protect against this particular fire hazard? Well, in the U.S., and I'm sure you're familiar with this document here in Columbia, mainly because for about 4 or 5 years I was down here in Bogota and Medellin teaching this topic. So I know we know about it in PA 13 here. But it says nothing about protecting lithium-ion batteries. As a matter of fact, it has a section in the annex of the standard that says this standard does not cover the protection of lithium-ion batteries. Now what do I do? So, one document that does exist is, and this just came out this year, is Factory Mutual's Property Loss Prevention Data Sheet 7-112. So, Factory Mutual has published this guidance. To my knowledge, it is the only document that exists right now that actually provides any guidance on how to design a sprinkler system to protect lithium-ion batteries. It divides, FM 7-112 divides the protection into these 6 areas. So it says basically the first one is general requirements of the storage and how it's manufactured. So it's going to provide kind of a general overview of the overall process of manufacturing of lithium-ion batteries and how it's to be protected. Then we get into the formation and aging areas. Now, formation and aging is a process in the manufacturing of the batteries where the batteries are literally put under their first stress test. And that stress test is they're powered up and then depleted. They're powered up and then cycled in and out of full power. This is the area within the manufacturing process where there is the most potential for there to be thermal runaway. So Factory Mutual 7-112 establishes specific design guidelines for systems that are protecting these areas. So it's separated out. There's the general manufacturing, and then it goes into formation and aging. And mainly because there's a lot of different formats that you can have for formation and aging areas. Some of them can be open frame rack, some of them are in bin boxes, and some of them are just in racks in the sprinkler design. So once they've gone through, once the batteries have been manufactured and they've gone through the formation and aging process, then it's a question of where do they go from there? Do they go into a finished product? All right? Or are they part of what we call incidental storage, which is they're batteries that are being used in another process? They may be going into bikes. Okay, or other small vehicles. They may be going into hoverboards or anything else like that. But what they're doing is they're stored right in the manufacturing process. They're used, put into the bike, and shipped out. So that type of incidental storage then has its own protection scheme, its own protection design guidance for fire sprinkler systems. But then we have the finished product. So the finished product area now, wherever that bike is now stored, before it gets shipped out, is now the finished product area. And that's under storage. That's another design criteria that goes into this. So we basically have the general requirements for the overall manufacturing process. Then we have the formation, age, and aging areas. Then it gets shipped out to finished cells that's incidental being used in the process. And then finally, the cells within the product themselves. Now, item 5 then becomes the storage of the batteries. And basically, what if they come out and be manufactured and they're not in incidental storage or they're not in the final product? They're simply being stored as batteries to be shipped off to somebody else. That's a different design criteria. All of these things, including ASRS storage, which is automated retrieval systems, which is another challenge altogether when it comes to sprinkler systems. But all of these design parameters and design guidance is provided to you in 7-112. Okay, so that gets us through the process. It provides the sprinkler designer with some sort of guidance as to how much water is going to be needed. What is the density of the design of the water that's required? Cool. Now, this particular facility is an example of it being a continuing challenge. This is a facility in Gdansk, Poland, which earlier this year experienced this fire. A number of vehicles charged by using lithium-ion batteries, there's an added concern and added need for guidance. The evolution of the hazard has been pretty amazing over 100 years. 1924, most of the vehicles that we were seeing that were constructed of non-combustible materials. All right, including the gas tank. So the gas tank itself was also made out of steel. That's not the case with new vehicles. New vehicles have a lot more plastic in them, including the fuel tank. So once if we get a fire going in a vehicle and it bursts the fuel tank, now you have a run-in pool fire. And that's what's caused the major fires in those parking garages. But now we've also gone up to the 2026 Honda Afila, which again is loaded with plastic, but also is powered by lithium-ion batteries. Now, when it comes to the protection scheme for parking structures, basically the International Building Code, the 2024 edition, has said everything that's an enclosed parking structure needs to have fire sprinklers designed into them. All right? Sprinklers in open parking structures is limited to very small areas, very small open parking structures. But even so, that's a little bit, that's a challenge in and of itself. All right, open parking structures with no sprinkler protection. Now I'm loading them up with lithium-ion batteries vehicles. Now, typically what happens then is if we look at the other standards now, we look at NFPA's side of things, the NFPA building code and the life safety code both say all parking structures, regardless of whether or not they're open parking structures or enclosed parking structures, they need to have a sprinkler system in them. And now you go to two other documents from NFPA for even further guidance on this. NFPA 88A is the standard for parking structures. And it says all parking garages also need to be protected. Now, we get to NFPA 13 then for the guidance on how to protect them. How do we protect car parks? And we see that there are some differences in the approach depending on whether or not this is just a standard parking structure with automobiles on the surface, or we've got what we call car stackers. So if I have car stackers involved with this, it's going to increase the design parameters and the design requirements for the sprinkler system. Car stackers have the capability of blocking. If I have a sprinkler system right here, you can see I have sprinkler piping right here, but now by raising an automobile up and then having a car come in underneath, we have the potential for what we call a shielded fire. The automobile up here, or even the shelving here, can cause the system to be blocked, the water spray to be completely blocked. Now, that being said then, one of the challenges here is this is what it looks like. One of the design parameters, by putting sprinklers up in here, it's an extra hazard group 2, so that's considerably more water than a standard ordinary hazard occupancy. But again, we can set it up so that we've got sprinklers at the ceiling, or we can set it up so that we have sprinklers at the ceiling and then maybe put a sidewall sprinkler underneath to provide protection there. Factory Mutual also contains guidance for these, but they are based. That's pretty much based on the height of the racking. All right, you can have car stackers all the way up to 4 levels up or more, and depending on the height of the ceiling, then basically we have a different design parameter based on these documents, 7-15 and 3-26 on non-storage occupancies. ISO also is looking into, the International Standards Organization is also looking into now the possibility of, or they have a document, got to have this, you need protection in these spaces. Now think of that one, and again, go back to automated parking structures. There wasn't anything going on with this vehicle. It was just parked in the parking garage. The damage had occurred at some other point. It could have occurred in manufacturing. We don't know. But you've got a fire going. How do we protect against it? Now, once again, when it comes to parking structures, when it comes specifically to protecting electric vehicles, there's not a lot of guidance. NFPA 13 doesn't provide any guidance on sprinkler system design, NFPA 88A, which is the standard for parking structures, doesn't provide any kind of guidance either, as far as how much water I should be designing. Now, that leads us to a challenge, because when there's no national guidance on these things, when we don't have any national standard guidance, what's going to happen is you're going to get the city of San Francisco here at the top. They're going to come out with their own design guidance just for the city of San Francisco. The state of California is going to do the same thing, only they're going to do it for the state of California. Now you're going to start to see, without any kind of national standard, you're going to start to see a lot of different design parameters. And the industry is not going to know what to do, where to do it, what the requirements are. What there has been, though, is considerable discussion amongst the fire officials, fire protection engineers, the insurance companies, and they have started to provide some level of guidance. Not published yet, but there is some understanding of what we will just say is a conventional means of protecting electric vehicles. And so it comes in a couple of different parts. First and foremost, electric vehicles are only going to be placed on the first level of the parking garage. That's it. Second, the recommendation is that they always be placed on the outside perimeter. All their spaces are on the outside perimeter of an open parking garage. That allows for the fire department to have access to the vehicles. All right? So, first level only, open parking structure, and around the perimeter of the building. Second, separation, not just here, but minimum separation between vehicles, and then larger separation between those and the combustible, the internal combustion engine vehicles on the other side of the driving lane. Absolutely automatic sprinklers are part of the recommendation, regardless of its open parking structure or an enclosed parking structure. So we've got that. Now, what comes along with the EVs is not just the vehicles, as you will know, it is also the charging stations. So where do the charging stations get their power from? They get it from energy storage systems. Energy storage systems can be placed, these are larger batteries that basically take the power from the grid, take it into an ESS, and then distribute it out to the charging stations. So there's